We now have to consider some standard integrals. But first, a review. You have to know how to take the derivatives. In order to get to integrals, you have to know how to take the derivatives. The derivative of sine is cosine x. We're not talking about the chain rule. Let's take some very easy examples. The derivative of cosine is negative sine x. The derivative of tangent is secant squared x. The derivative of e to the x is e to the x. The derivative of natural log is 1 over x. You have to know these cold inside, outside, backwards, and upside down. Once you know those, you can move on to the integration. The antiderivative of cosine x dx is sine x plus c. The integral of sine x dx is negative cosine x plus c. The antiderivative of secant squared x dx is tangent x plus c. The integral of e to the x dx is e to the x plus c. And last but not least, the integral of 1 over x dx, or this is x to the negative 1 dx, is natural log x plus c. These are the building blocks. If you don't know these inside, outside, upside down, and cold, both the differentiation and the integration, then you really can't move on. It's worth your while to sit and memorize these because they're going to help you so much later on. Continuing on here with our standard integrals, we have to remember the chain rule for differentiation. The chain rule for differentiation, our key for that was that when we had parentheses with something besides just x in it, for example, we have 2x here, we're going to need to use the chain rule. The derivative of sine is cosine of what? Of 2x. Now we had to, if we defined that as u, we had to take du dx, which was times 2. So ultimately, our derivative was 2 cosine 2x. The key concept there for the chain rule was that we multiplied by whatever the derivative of the parentheses was. When we're taking the integral, instead of multiplication, we think division. Well, what's the antiderivative of sine? It's negative cosine of what? Of 2x. Now, instead of multiplying by 2, I'm going to divide by 2. Or you can think of that as multiplying by 1/2. With the differentiation process, we multiplied. Taking the integral, we divide by whatever that constant is. Okay, after all of that build-up, we're finally ready to look at some standard integrals. We've already seen this one before, but I think it's worth repeating. If I take the integral of ax to the n dx, I get a times x to the n plus 1 divided by n plus 1 plus c. For example, the integral of 2x squared dx is 2 times x cubed divided by 3 plus c. If I take the integral of 1 over x dx, I get natural log, or log base e, x plus c. For example, the integral of 6 over x dx is really the integral of 6 times 1 over x, which we can write as 6 times 1 over x dx. I can split that 6 out because it's just a constant. I know that the antiderivative of 1 over x is natural log x, so this becomes 6 natural log x plus c. Here's our first constant we see, the integral of sine kx dx. Well, that's sort of the opposite of the chain rule. It's going to be negative cosine kx divided by k, or times 1 over k. For example, the integral of sine 5x dx is negative cosine 5x plus c. Now I have to divide that by 5 or multiply by 1 over 5. Either way is okay. Continuing on with our standard integrals, we look at the antiderivative of cosine kx dx. That becomes 1 over k sine kx plus c. For example, cosine x over 4 dx. Well, that's really 1/4. Our coefficient there is 1/4. So our answer will be sine x over 4 plus c. And now we have to remember to divide by 1 over 1/4, which is really, if I have 1 divided by 1 over 4, that's really times 4. So there is my answer to that first one. If I have the integral of secant squared kx dx, I'm going to get tangent kx plus c all over k. For example, the antiderivative of secant squared 2x dx is 1 over 2 tangent 2x plus c. Again, it's sort of the opposite of the chain rule. We have to divide by whatever that constant is there. If I have e to the kx dx, I'm going to get 1 over k e to the kx plus c. For example, in this case, it's e to the negative 3x, so I'm going to get 1 over negative 3 e to the negative 3x plus c for my answers.